Hello everyone, I am Windu Antara Kesiman. I am from Virtual Vision Image and Pattern Research Group, Faculty of Engineering and Vocational, Universitas Pendidikan Ganesha. We would like to welcome you first in this session for the IConVET 2020. We would like to present our work on a model for post-transliteration suggestion for Balinese palm leaf manuscript with text generation and LSTM model. Here is our research background. So this work is under a big project from 2014 and continue also this year. We have a project in digitalizing the Balinese palm leaf manuscript, but not only to create a digital image. We also try to develop an automatic machine for the transliteration of the Balinese image manuscript into the Latin or Roman alphabet. In the previous works, we already developed two types of transliteration system. The left one is the segmentation-based transliteration. In this case, we work first on the glyph segmentation and the glyph recognition, and then we build a phonological rules to do the transliteration from all detected and recognized glyph. The second type of the transliteration is the segmentation-free transliteration. In this model, we are not doing any segmentation for each glyph and not to recognize each glyph separately, but we work directly on the segment of word and the transliteration text. In segmentation-free transliteration, we are using a deep learning of LSTM model. So in this presentation, we will continue our work on developing a post-transliteration suggestion for the transliteration text that already produced in the previous work. Here you can see that on the left, the green rectangle is the previous work where we are already developed an OCR transliteration module with the word recognition module, and then we also develop a transliteration system by using LSTM model and also with the phonological rules model. Now we want to improve our result in transliteration text by proposing a post-transliteration suggestion with text generation. So in final goal to propose several transliteration suggestions. You can see, for example, from the image of Dharma in the Lontar segment, we have the result of Dharma without an A, so there is an error in transliteration text. Now we want to propose some suggestions about the corrected transliteration text. For example, Dharma, Drama, or Dhamma. So for this work, we're still working on the corpus and dataset proposed in Amadi Lontar set. The Amadi Lontar set is the Balinese manuscript image collected from 5 different regions, 2 from region, 2 from museum, and 3 from private family collection. And we have 23 different Lontar collection, which is 10 from the Museum Gedung Kertie, 4 collection from Museum Bali, and other collections are from private family from village of Jagaraga, village of Susut, and village of Rendang from different regency in Bali. In total, we have 393 pages of digital image of Lontar. Normally, most of the page of Lontar consists of full-line text. So we have as well as 4 transliterated texts. And from this whole collection, we collected 1,458 lines of transliterated text. These transliterated texts are already validated by the Balinese philologist. And from whole collection, we collected 25,000 word segments. It includes 52,000 total correct characters. But we only have 7,208 different unique words with the vocabulary of characters. It consists 38 unique characters. You can see here the thumbnail samples of the word segments from Balinese Lontar, and we extracted the transliterated text of each word. So we obtained 7,208 different word collections, and we will work from this different word text collection for our text generation model. So here is the proposed model and method. We call it the edit, insert, replace model. Actually, the goal is to develop a bigger data set which consists not only the correct transliteration text, but also the wrong text. So to generate the wrong transliterated text from the correct transliterated text, we applied three different modifications: the edit, insert, and replace. So for example, if we have a correct word trained with a length of character n, we will produce n times 4 couples of input and target words. The input words will be the wrong generated text from the correct transliterated text. We will do the edit modification, the insert modification, and replace modification with a random character in each position from the 0 position until n-1. So the number of the wrong generated word from this model will be depend on the length of the original correct word. On the table on the right, you can see, for example, if you have a word Brahma, it is 6 character length. In the final text generation model, you will obtain 24 different word. Okay, so from modification character position 0 to 5, we will apply the modification model of edit, insert, and delete. For example, in edit, the Brahma will be replaced by Rahma because the first character B is replaced by character Y, and then we can also insert one character in Brahma. For example, here 6 Brahma, why 6? Because number is also a possible wrong character in our transliteration text, and so on. So with this model, now we can produce a wrong transliterated text and also the correct transliterated text to be trained to be fit into our LSTM model. So the proposed model and method in text generation, it will be only carried out on words that have a length at least 2 characters. Why? Because we consider that if the transliterated text in the previous system produced only a text with 1 or 2 character in length, we consider that it is mostly correct, because for 1 character, it should be, for example, a punctuation mark, and for 2 characters, it is normally only 1 character, and our previous system can recognize well 1 single character or glyph from the Balinese script. So from a collection of 7,208 unique words in the previous dataset, now we have 180,060 generated words. During the test, we also applied a text generation for the query, and we also applied this model only for a query with length at least 2 characters. Now we will move to the feature extraction. For the feature extraction method, we propose that we are using the combination of the 2 characters before and 2 characters after the position of a character that will be checked for a correction. So the basic features will have a size of 4. For example, in the word Brahma, and first position is 0. So we applied the edit model first. In this model, we have a sequence edit. we should add the padding character of star in the two previous positions and the two last position. Why? To make it sure that all the feature feature extraction will be complete, because the first character of the word and the last character of the word doesn't have two previous and two sequence after their last character. So we applied a padding character of star. So Brahma will be becoming star, star, Brahma, and star, star. And for sequence edit Yerahma, it will becoming star, star, Yerahma, and star, star. Now, we have to convert the character into the numerical value. We are using the vocabulary number of the unique characters. So from 0 to 37, 37 will be the character of star because we are using it in special purpose. So for example, the word Brahma, the numerical value will be 37, 37, 15, 29, and so on. And for the edit model Yerahma with the star, it will be 37, 37, 34, 94, and so on. So you can see here that the number of 15, it should be B, have already replaced with 34. It is an Y, because here we will train the model to correct Yerahma becoming Brahma. The target model, it will be still the same, the correct word of Brahma. Now we will extract the feature by looking at two characters before and two characters after for each position of the characters in this convert in and convert edit numerical value. So from the convert edit, we will have the first feature. It is 37, 37, 29, and 14 because we are checking the first position of 15, and then we continue to check this position of 29. The two previous character is 37 and 15, and then 40, 20. Okay, so the length of the feature is 6 factor. Each factor consists of 4 character or 4 numerical value. And the target word out label, it is the same of feature extraction model for the word Brahma. So for the LSTM model, we have to produce the same length of feature. So we define here a padding of our feature factor. We choose a fixed value of 10 characters. It means that our convert edit should be 10 factor. For the padding factor, we are using also the star character. So for example, here, the convert edit of Brahma, the 4 last factor will be consist only the star. You can see here the 4 last factor of 37, 37, 37, 37, 4 times of that factor. And for the target label, we also add as a padding characters becoming 10 length, we added a 37 in the last 4 numerical value. And then we converted it into categorical form based on the number of vocabulary of letters. We have 38 unique characters. The whole process, for example, we have to apply the whole process for each of model edit, insert, replace for those 24 generated input words from the original word of Brahma. And finally, we will reshape the feature into NB word maximum pad for size of the factor. So, for example, one word of Brahma with length 6, we will finally get a factor of feature with the size 24, 10, and 4. Okay, and the target label for that trained word is 24, 10, and 38. Why 38? Because in the target label we change the numerical value into categorical value of each character. So from the whole data set, if we have a 180,060 generated word from all total collection, finally the final feature for all data is 180 and 60 times 10 times 4 for the trained data, and the final target is 180 and 60 times 10 times 38 for the label target. And this X and Y data will be fed to the LSTM model. To train our LSTM model, here we are using the bidirectional LSTM. Why? Because we consider in our hypothesis that the model should be trained from two directions, as we generated our feature from two previous and from two last character between the word. So we think that our hypothesis says that the bidirectional model will be very suitable in this case of learning method. So we just defined that we are using the optimizer Adam with the loss function or mean square error, and for the final network we are using the dense network with the activation softmax layer. We applied the epoch of 100 for each training process, but finally we will train our model more than 100 epochs. So we will apply n times of model training. Each training will consist of 100 epochs, and we will also apply the validation split to calculate the validation performance with the batch size of 1000. And we applied the same model for the prediction step or the test step. For the query generation, as we already explained in the previous slide, we also apply the same model of edit, insert, delete. So if you have, for example, one original query text with the length of n, we will finally produce 15. Why? Because first we have the original query, and then we edit the modified model from edit, insert, replace model. It depends on the number of character in the original word. Here, for example, if the query is D-RMA or Dharma with the wrong character in the third character A, we will finally have 15 different 16 different, so 15 plus 1, the original query, to be tested to propose a new suggestion for the transliteration. Here is the result of the training process. We show here the loss value evolution during the training process until 1300 epoch. So as we already explained, we applied the training for each 100 epoch, and here is the result after 1300 epoch. You can see here that our model learned very good in doing the suggestion from the wrong transliterated text into the correct transliterated text. So because we applied a validation data set here, so the train is applied for 144,000 samples and validate on 36,000 samples. Here we present the result of our prediction part. For example, the word D-RMR, or the correct transliterated text should be Dharma. From 16 possible suggestions, our model proposed in three correct suggestions: Dharma, number 1, number 9, Dharma, and number 12, Dharma. So you can see here that our model are able to propose in some position the correct transliterated text of Dharma. On the right table, you can see here more example. For example, the word Dewa, because it should be Dewa, and then Surga, it should be Swarga. Also the word Kawastanin. You can see here in the bold part where our system are able to find the correct suggestion from the wrong result of the transliterated text. You can see, for example, in the last example of Aksraning, it should be Aksaraning, and our system are able to propose in 1, 2, 3, for five suggestions of the correct aksaraning word. This this system is already integrated to our previous system of Axolon, where the first machine of Axolon produced the first step of the transliterated text, and then the second module will be propose a possibility of the correct transliterated text if the user found that the first result of the transliterated text is not really correct. So we already integrated the system on our Axolon model. For the conclusion, so here in our work, we already did the initial study and proposition for a model, a general scheme for suggesting several possible transliteration text with our proposed text generation model and LSTM for Balinese family manuscript. We are using the edit, insert, replace model to be applied on the existing word collection dataset to do the text generation. And the bidirectional LSTM model are very suitable to solve this kind of problem. And now our proposed model is able to help in suggesting several possible transliteration to help the user to find a correct transliterated text from a wrong transliterated text from the previous system. Of course, a future improvement is still needed because in some part our system has still failed to propose some suggestion in transliterated word. We can add some more additional data in the future improvement, and also we can train doing the parameter tuning in our LSTM model to get a better model for our suggestion in transliteration text. So that's our presentation from our work. Thank you for your attention, and we can continue to the question and answer session. Thank you very much.